Hello everybody, thank you for joining today. My name is Willem and today we're going to be talking about lenses. Now this is a bit of a long video, so get strapped in. Some of our learning objectives are as follows: to understand the two main types of lenses, to understand the different types of rays, to recall and understand the following words: focus length, principal focus, real and virtual rays, and to know what determines the strength of a lens. Now, some things you already need to know is the principles of refraction, what refraction is, and how it affects rays of light. Alright, first of all, we're going to have a look at the two main types of lens you need to know about for your GCSE. Okay, we have convex lens and we have concave lens. Now, the biggest difference between these two lenses is the way that they bulge. Here we can see that convex lenses bulge outwards and concave lenses bulge inwards. Now, you can use something to help you remember which lens bulges which way. Here we have my very bad drawing of a cave. Now a cave bulges into the earth, therefore concave lenses, so here let's do cave inwards equals concave inwards. So now if you understand that concave lenses bulge inwards, you also understand that convex lenses, the opposite, bulge outwards. Okay, so here we have the two main types of lenses. Now let's have a look at what they actually do. Now a convex lens is also called a converging lens. This is because it takes separate light beams here, as you can see here, here, here and here, and it converges, it brings them together at a single point here, the focus point. So let's write that here: converges, bring together separate light rays to a single point. Now a concave lens does the exact opposite. It's a diverging lens. It spreads out separate beams of light into even further separate beams of light. So this is called a diverging lens. The beams spread out. Now, you may be thinking, oh, the convex lens has a focus. Does the concave lens not also have a focus? Well, you'd be right, it does. But I have to introduce something new to you called a virtual beam. I'm going to get into more detail about real and virtual in a second, but for now, just bear with me. I'm going to draw a virtual beam coming back out of the lens here, and also out of the bottom. Now, the point at where these lenses crossover or intersect, this is the concave focus point. Now, you can often hear this be called the focus, the focal, or the principal focal point. These are all interchangeable words. They all mean the same thing. But I'm just letting you know that in case you come across them and you get confused. Now, you understand the two main types of lenses, what they do to light beams incident upon them, and you know a little bit about real and virtual beams. Now, that's what I'm going to get into next. Oh, also, the distance between the focus point here and the center of the lens is called the focal length. So that is the focal length. And let's do it in red. Here and here. This is also the focal length. I'm going to write up a definition for you up here. Focal length equals distance between focus point and center of lens. Now, the focal length is actually a very important concept because the shorter your focal length, the more strong, the more magnifying or minimizing your lenses. But we often just use the word strong. How strong a lens is. That depends on the focal length. Shorter focal length, stronger lens. Alright, so now I'm going to talk to you about real and virtual rays. Now, this is something that confuses students a lot, so please pay careful attention. So, first of all, we want to understand that images are formed where light rays from a particular spot on an object appear. But all that means is that images are really come from certain pieces of light coming from certain places. Now, what does this have to do with real and virtual rays? Now, real rays, or rather real images, are formed behind the lens and let's do here, can be projected, and they're formed where the rays actually converge. So here I have an extremely crude and kind of rubbish drawing of the human eye. So if you look at the human eye shape here, what sort of mirror is this? Sorry, not mirror, lens is this? If you said convex, you are right. The human eye is a convex lens. Here we can see my, stickman with no arms. Let's put his arms in. Being all the light rays coming from the top of the stickman's head and the bottom of the stickman's legs, they're going through the eye, the convex lens here, and here we're seeing all these light rays at the back here converge. You don't really need to understand these light rays right now. I'm going to do a separate video on that, but just to represent light being light traveling. All the arrows as well. Here we can see an upside down image of the stickman being formed behind the lens. So this would be onto our retina, and actually everything that we do see in the real world is technically upside down, just our brain has adapted over thousands of years to flip those images straight away, which is why we see everything this way up. And so for a real image or real rays, they're always formed behind the lens. They can be projected, and it's where the rays of light actually converge. Now let's move on to virtual rays. Here we can see the stickman being formed in front of the lens. So image is formed in front of lens. This image is virtual, and this is because the rays of light do not actually converge at that point. Because remember, this type of lens here is a concave lens. It's a diverging lens. It makes all the rays of light incident upon it diverge, spread away from each other. So really, they don't actually come together behind the lens at all. Only the virtual rays in front of the lens seem like they're coming together, and so we see the object over here, when really there are no rays that actually produce that object by crossing there. So therefore it's a virtual image over here. Now virtual images are also a common example is a mirror. If we have a mirror here, right, and a stickman standing here, and he's looking at his reflection